All right, today we're going to be looking at the Unit 9 test review for solving quadratic equations. So on 1 through 6, we are just determining which method would be the best method to choose. So we have DOPS, GCF, or trinomial. Remember that DOPS is ax squared minus c, GCF is ax squared plus bx, and a trinomial is ax squared plus bx plus c. So we can look at the number of terms we have, and that will narrow it down to start off with. So number 1, we have 2x squared minus 8x. There are only two terms, which makes it a binomial, so it's either DOPS or GCF. When I look at my terms, both of these have an x, which makes it GCF. All right, number 2, I have x squared plus 8x minus 21. I have three terms, which makes it a trinomial. If I wanted to go a little further, this would actually be what we call a simple trinomial, because the number in front of the x squared is a 1. All right, number 3, I have 9x squared minus 81. It is two terms, which makes it a binomial, so I'm either looking at a DOPS or a GCF. If I look at both of my terms, only one of them has an x in it, which makes it a difference of perfect squares. Number 4, I have x squared plus 25x. Again, I have two terms, so it's a binomial. So it's either DOPS or GCF. If I look at these, both of them have an x, which makes it a GCF. 5, 2x squared plus 12x minus 35. I have three terms, which makes it a trinomial. If I wanted to go one step further, this is actually a complex trinomial, because the coefficient in front of the x squared term this time is something other than 1. Alright, right here, before I can determine what I have, I need to go ahead and distribute that x through so that I can see all of my terms written out. Once I do that, I have an x squared plus 9x minus 12. I have three terms, which makes it a trinomial, and it is a simple trinomial because the number in front of x squared is in fact 1. Alright, so on 7 through 10, we are factoring these four quadratics, and then we are determining which one it matches over here. So on the first one, I have x squared minus 25. It's a binomial because it has two terms, and only one of my terms has an x in it, which means that I know that this is DOPS. In order to factor DOPS, I take the square root of the first term, so the square root of x squared is x. I take the square root of the second term, which is 5. One of them is addition, and one of them is subtraction. So if I look over here, I'm looking for an x plus 5, x minus 5, so C. All right, number 8, we have a trinomial. So I'm going to look at 1 times 15, so I have 15. I want to list all my factors of 15. Because the 15 is positive, I'm looking for the two that add to give me a negative 8. Since they add to give me a negative 8, I know that they are both negative. So if you want to use box method, and I have a negative 3x and a negative 5x. So I'm going to GCF, x squared and negative 3x have an x. X squared and a negative 5x have an x. Negative 3x and 15, negative 3. Negative 5x and 15, negative 5. So my factors are x minus 3, x minus 5. So we are looking at A. 9, again, I have a simple trinomial. This time I'm going to do the other method, where since it is simple, I'm looking for the factors of 15 again. And this time they're going to subtract to give me 2. So I still have 3 and 5. I'm just going to go straight into my parentheses. Now, there's different combinations. So I need the difference of the 3 and the 5 to be a negative 2. Which means I need to have 3 minus 5, so my 5 is negative. So this time I need x plus 3, x minus 5, so h. Okay. All right, number 10 is another trinomial. So you can either do box or you can go straight into your parentheses. It is positive all the way across, which means these are going to be positive all the way across. X, x. I'm looking at 6, so I'm going to list my factors as 6. I'm looking for the 2 that add to give me 5. So 2 and 3. So now I'm looking for x plus 2, x plus 3, e. Okay? Remember that on simple trinomials, if you prefer to use the box method, you can still use the box method. It's just a little bit extra. All right, on 11, 12, and all the way through 21, we are going to go ahead and decide which method we're using. We're going to then factor it, and then we are going to solve it. So on this one, I have a complex trinomial. I'm going to do 5 times 6, gives me 30. Now I'm going to list all my factors of 30. Because the 6 is negative, I'm looking for the 2 that subtract to give me 13. So I get 2 and 15. So I'm going to go ahead and put those in my box. So 5a squared negative 6. Again, I need them to subtract, but I need them to subtract to give me a negative 13. So that means I have a negative 15 and a positive 2. All right, so now I'm going to GCF. So 5a squared and a negative 15a both have a 5a. 2a and negative 6 both have a 2. Going to go down, so 5a squared and 2a, they both have an a. Negative 15a and negative 6 both have a negative 3. So my factored form is 5a plus 2, a minus 3. So if I'm going to solve them, I'm going to set each factor equal to 0 and solve. So this one's pretty easy. I'm just going to add the 3. So one of my solutions is 3, 0. Right here I'm going to go ahead and subtract the 2, so I get 5a equals negative 2. And then I have to divide by the 5. So my other one is negative 2/5. 0. Oops, sorry. Alright, 12. Again, we have 2x squared minus 3x minus 9 equals 0. So this is a trinomial. It is a complex trinomial, so I'm going to do 2 times 9, which gives me 18. And now I'm going to list all my factors of 18. Because the 9 is negative, I'm looking for the 2 that subtract to give me 3. So I've got 3 and 6. So we're going to fill in our box. I need these to subtract to give me a negative 3. So I know it's going to be a 3 minus a 6. And now I'm going to GCF. So 2x squared and a negative 6x have a 2x. 3x and negative 9 have a 3. Now I'm going to go down. 2x squared and 3x have an x. Negative 6x and negative 9 both have a negative 3. So my factored form is x minus 3, 2x plus 3. Okay. To find my solutions, I'm going to set each one of these equal to 0 and solve. So right here is easy. I'm just going to add the 3. And right here I'm going to subtract the 3 and then divide by 2. So I get negative 3/2. Okay. All right, let's look at the back side. So I know these are crammed in here pretty tight, but some of them will be pretty easy to factor. So right here, I have 2 terms, and only one of them has an x, which makes this a dots problem. So I have my 2 set of parentheses. Take the square root of 49x squared is going to give me 7x. Square root of 100 is 10. I make one of them positive and one of them negative. So there is my factored form. Now to find my solutions, I'm going to set each one of these factors equal to 0 and go ahead and solve. So right here I'm going to subtract 10 and then divide by 7. So negative 10 over 7. And remember with dots, because they are the exact same factor, just one of them is positive and negative, then my answers are going to be the exact same, just one of them positive, one of them negative. Alright, on 14, the first thing we need to do is get everything onto one side and have it equal to 0. So I'm going to get x squared plus 4x minus 12 equals 0. I have 3 terms, so it is a trinomial. It is a simple trinomial, so if I want to just go straight into my parentheses, I can. So I'm going to list my factors of 12. And I'm looking for the 2 that subtract to give me 4. I need them to subtract to give me a positive 4. So I'm going to have an x plus 6 and an x minus 2. So now if I want to find my solutions, I'm going to set each one equal to 0 and solve. So right here I'm going to subtract the 6. And right here I'm going to add the 2. So there are my 2 solutions for that one. Alright, on number 15, I have 2 terms, so it is a binomial. Only one of them has an x, so it's a dots. So with dots, I put my 2 parentheses. I take the square root of the first term, so the square root of 64x squared is 8x. And I take the square root of the second term. One of them is addition and one of them is subtraction. So there is my factored form. And to solve, I'm going to set each one equal to 0 and get x by itself. So I'm going to subtract 5 and then divide by 8. So negative 5/8 and positive 5/8. Okay. Alright, 16. Before I can do anything, I do need to get everything onto the same side and have it equal to 0. So I'm going to add this 35x to the other side. I have 2 terms, which makes it a binomial, and both of my terms have an x, so this is a GCF problem. So I'm going to draw my box, and remember I only need a 1 by 2 this time, so 10x squared and 35x. So 10x squared and 35x, what is the largest number that goes into both? It's a 5, and then they both have an x. What would I need to multiply 5x by to get a 10x squared? It's going to be a 2x. And what would I need to multiply 5x by to get a 35x? It'd be a positive 7. So my factored form is 5x, 2x plus 7. And my solution, again, just set each factor equal to 0 and solve. I'm going to divide by 5, which is just going to give me 0. Over here, I'm going to subtract the 7 and then divide by 2. So negative 7 halves, 0. Okay. 17, I've got 2 terms. Both of them have an x. So this is another GCF problem. So I can draw my box. So x squared negative 3x. The most that both of them have in common is an x. So what would I need to multiply x by to get an x squared? Another x. What would I need to multiply x by to get a negative 3x? Be a negative 3. So in factored form, it's x times x minus 3. So if I solve, well, that one's already solved. And over here, I'm just going to go ahead and add my 3. All right, so number 18. We need to move this 4x over. So I'm going to get x squared minus 4x minus 21 equals 0. I have 3 terms, so it is a trinomial. It is a simple trinomial, so I can go straight into my parentheses. So my number is 21. I'm going to write all my factors of 21. Because 21 is negative, I'm looking for the 2 that subtract to give me 4. So 7 and 3. I need them to subtract to give me a negative 4. So 7 is going to be negative and 3 is going to be positive. If I want to solve, I'm going to set each factor to 0. Right here, I'm just going to add the 7. So I get 7, 0. Over here, I'm just going to subtract the 3. Okay. All right, we've got 3 more of these. So right here, I want to move everything onto one side. I like my squared term to say positive, so I'm actually going to move everything over to that side. So I get x squared plus 19x plus 88. 3 terms. So it is a trinomial. It is a simple trinomial, so I can go straight into my parentheses. I need to list my factors of 88. 4 and 22. 5, nope, 6, and 7, no, 8. And I'm looking for the 2 that add to give me 19. So I have 8 and 11. They're positive all the way across, which makes these positive all the way across. So if I want to solve, I'm going to set them equal to 0 and get x by itself. So I'm going to subtract 11. So I'm going to get negative 11. And then I'm going to subtract 8, and I get negative 8. All right, on number 20, I have 2 terms. Both of them have an x, so this is a GCF problem. I'm going to go ahead and draw my box. So I have a 12x squared and a 21x. So what is the biggest number that 12x squared and 21x have in common? Well, they're both divisible by 3x. So what would I need to multiply 3x by to get a 12x squared? 4x. And what would I need to multiply 3x by to get a 21x? A 7. So factored form is 3x, 4x plus 7. And now if I want to solve them, set them both equal to 0. And get x by itself. So when I divide by 3, I just get 0. Over here, I'm going to subtract the 7. And then divide by 4. So I get negative 7 fourths. Okay. And last one like this, I need to get this 8x, this negative 8x onto the other side. I'm going to go ahead and add it. 2 terms. They both have an x. So GCF. Draw in our box. So I have an x squared and then 8x. So what do an x squared and an 8x both have? An x. What would I need to multiply an x by to get an x squared? X. And what would I need to multiply an x by to get an 8x? 8. So x plus 8. If I want to solve, I'm going to set them both equal to 0. This one is already solved, so 0, 0. Right here, I just need to go ahead and subtract that 8, and I get negative 8. All right. So we did a little bit of all of them. We did complex trinomials, simple trinomials, dots, GCF. All right. So flip on over to the other side. Some of these are going to be multiple choice. So if I want to know what are the solutions to 2x squared minus 10x equals negative 12, I'm asking you to solve. Which means first thing I have to do is factor. So I need to get everything onto one side and have it equal 0. Well, this one is a complex trinomial, so I'm going to do 2 times 12 equals 24. And now I'm going to list all my factors of 24. And I'm looking for the two that add to give me 10. So 4 and 6. I'm going to put them in my box. Now, they need to add to give me a negative 10, which makes them both negative. So 2x squared and negative 4x have a 2x in common. A negative 6x and a 12 have a negative 6. Going down, 2x squared and a negative 6x have a 2x. Hold on. Did I do that right? 2 times 12 is 24. Oh. If I look at this original problem, everything is divisible by 2. So I'm going to get this. Now, it's a simple trinomial, so your factors become 6, add to give you 5, so I get x minus 3 and x minus 2, but if I solve these, they both become positive, which is A. Alright, so this actually was a GCF problem and a trinomial problem, because they all had a 2, and then I could factor. Alright, 23. So what are the x-intercepts of the graph 2x squared minus x minus 1? So this, 2 times 1 gives me 2, and my factors of 2 are 1 and 2. So if I fill them in, 2x squared minus 1. When I subtract them, I need it to be a negative 1, so I need the negative to be on the 2x. So now 2x squared and negative 2x have a 2x. X and a negative 1 just have a 1. 2x squared and an x have an x. A negative 2 and a negative 1 have a negative 1, which makes my factors 2x plus 1 and x minus 1. So negative 1/2 and 1. So negative 1/2 and 1. Alright, on 24, you are just factoring to see which one is equivalent. If for any reason you cannot remember how to factor, you could always go backwards and re-multiply these out to see which one gives you that. Oh, but if I do 6 times 28, that's going to give me, I get 168, and now I need to list all the factors of 168. Does 3 go in there? Yes, so 168 divided by 3 is 56. What about 4? 168 divided by 4. 42. 5 does not go in there. Does 6? 6 and 28. 7 and 24. 8 and 21. And they need to subtract to give me 13. So 8 and 21. That means when I put it into my box, I have 6x squared negative 28. And needs them to subtract to give me a negative 13. So negative 21x and positive 8x. So 6x squared and a negative 21x both have a 3x. And 8x and a negative 28 both have a 4. Okay. Now go down. 6x squared and an 8x both have a 2x. negative 21x and a negative 28 both have a negative 7. So I have a 3x plus 4 and 2x minus 7. So B. Okay. 25. Which of these is a factor of this trinomial? So if I do 4 times 2, get 8. So I'm going to list my factors of 8. And I need the 2 that subtract to give me 7. So we're putting it in my box. 4x squared, negative 2. I needed them to subtract to give me a negative 7x, so the 8 is negative. So 4x squared and a negative 8x have a 4x in common. X and a 2 have a 1. Now go down, 4x squared and x have an x. Negative 8x and a negative 2 have a negative 2 in common. So I have x minus 2 and 4x plus 1. So C. Alright, so I have negative 3.2x squared plus 80 equals 0. We want to know which one of these is a true statement. So I can actually graph this equation on my y equals since I'm dealing with decimals. So negative 3.2x squared plus 80. And if I graph that, okay, I can see that I do have two solutions. So I can get rid of no real solutions. I can get rid of infinite solutions. So if I look, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have negative 5 and 5 are my two solutions. On 27, we have a table. We're told that negative 3 is a solution to my quadratic, which means that up here at negative 3, y would be 0. What is another solution to this equation? Because I'm looking for where y is 0, because I'm looking for an x-intercept, I also have an x-intercept at 6, 0. Alright, what is the solution set for the quadratic equation x squared minus 9? Well, it's a binomial, and only one of my terms has an x in it, which makes this a dots problem. So if I factor, square root of x squared is just x. The square root of 9 is 3. I make one of them positive and one of them negative. So if I actually want to solve this, here I'm going to go ahead and subtract 3. So I get negative 3. Here I'm going to add 3. So I get positive 3. So 3 and negative 3 become my solutions. Okay. Alright, on 29 you are given the graph of a quadratic, and you are also given it in factored form. If it is already in factored form, all I have to do is set each factor equal to 0 and solve for x. So I have roots at 1, 0, and 5, 0. 30 and 31 are kind of a recap of the last unit. So the axis of symmetry, remember, is the line that cuts the parabola directly in half. So it should be directly in between these 2 points because they should be symmetric. So x equals 4. Okay. Right here, we want to find the corresponding point to the point 0, 9, and we're told that this point right here is our vertex. Remember, if that is our vertex, that is the line that cuts it in half. So these are corresponding points. So this would have a corresponding point at 6, 9. All right, make sure you study for your test.